The following is an explanation of example 6.3 found on page 247. We are told that we have a balloon that is being filled by heating the air inside. We're making a hot air balloon. In the final stages of this process, our volume changes from 4.0 times 10 to the 6th liters to 4.5 times 10 to the 6th liters by the addition of 1.3 times 10 to the 8th joules of thermal energy. Assuming that the balloon is expanding at a constant pressure of 1.0 atmospheres, what is the change in energy of the system? And we're given a conversion factor of 1 liter atmosphere equals 101.3 joules. In order to do this, we need the equation delta E equals Q plus W. Q is our heat, W is the work being done. We also need the equation work equals negative P delta V. If we analyze our question a little bit, we have a volume there and a volume there. If we take our final and subtract away our initial, we will get a delta V. So delta V equals 0.5 times 10 to the 6th liters. That's just a quick subtraction. Yes, we're not necessarily in correct scientific notation. However, it's good enough for the sake of argument. The pressure we're given as 1 atmosphere, so we can go ahead and calculate our work equaling 5 times 10 to the 5th liters, or if you'd rather have things in more common terms, I'm sorry, that should be a negative. Negative 5 followed by 5 zeros. 1, 2, 3, 4, 5. 500,000 liters. That's our work. So the balloon is expanding. As it's expanding, if we were to put something on top of the balloon, it would move. And the energy to move that object is coming from our air. I'm sorry, that's liters times atmosphere. However, liter atmosphere is kind of a bulky unit. We would much rather use the 101.3 joules. So we need to take our answer that we are given in liter atmosphere and go ahead and multiply it by 101.3 joules per liter atmosphere. When we do this, we get an answer of negative 5, 1, followed by 6 zeros. 5, 6. So we get negative 51 million joules. That's how much energy is lost due to work in this problem. However, we are adding some energy, and the energy we are adding is thermal energy. Thermal energy is also known as heat. Since we are adding energy, it's going to be a positive, so Q equals positive 1.3 times 10 to the 8th joules. All we have to do to find our delta E is take that positive 1.3 times 10 to the 8th joules, and we're going to add to it our negative 5.1 times 10 to the 7th joules. We do this, and we should get a number of 8 times 10 to the 7th joules. We get a positive number because our positive is a slightly higher exponent than our negative. So even though we are expanding the balloon and thus losing energy, we're overall increasing the energy of the system simply due to the sheer amount of thermal energy we are adding. Again, this is example 6.3 off of page 247.